Today we want to look at writing functions in C#. We've been using functions already in that we've written all of our code in event procedures, which are really a specialized type of function. Let's take a closer look at the event procedures that we've been using, and they follow a format in that it starts with a keyword of accessibility. We've been using procedures that are private, but we can also make procedures and functions public. And our event procedures have a return data type, as do all functions. And since nothing's being returned, the return data type for an event procedure is void, meaning it doesn't return anything. Our event procedures always had a name. Commonly, if we double-clicked on an object, it would create the event procedure for us with the name of the object, underscore, and the event. And then inside parentheses are parameters. We really haven't looked at those much yet this semester. But for event procedures, there are two parameters, and you'll notice they are comma delimited or separated by a comma. And they look like variable declarations. And that's really what they are. We have a variable here called sender, and another one called e. Sender is of a data type of a class instance, or an instance of the class object, and E has a data type of an instance of the class event args, or event arguments. Each parameter, then, is just like declaring a variable in that there's a data type and a variable name. And so sender and E we can treat as variables, and we can actually get information about the object and about the event itself that triggered this event procedure. Here's how we can use sender and E, or the parameters that are passed in the event procedure. So I'm going to take the value of E, which is of event args, and I'm going to cast it as a mouse event args, which is a subclass of the event args class. And the reason I'm doing that is because mouse event args has two properties, which are X and Y, and I can get the coordinates of where the user clicked. Event args includes events other than mouse events, but I know that the way I've got this built, that only a mouse event is what's going to trigger this event procedure. And the same with sender. I know that sender is going to be a button, and so I cast it as a button and put it into a button object named myButton. And then in the message box, I'm simply going to show the name of the button and the location where the user clicked. And that location is relative to the sender object. So if I click in the upper left-hand corner of button 1, it's going to tell me you clicked button 1 at location 0, 0. So it's the location of the object, or within the object, and not within the location of the window or the form. And of course, all three of those buttons I have linked in the properties within the events tab to this procedure called which button. Here's another example. I've got a picture box with an image that is separated into 4 quadrants. I've colored those blue, red, yellow, and green. And then I'm going to use the event args variable E, which again I'm going to cast as a mouse event and figure out the X and Y coordinates. And using those X and Y coordinates, I can figure out which square they clicked on inside that picture, which quadrant they picked on. So my picture is 200 by 200, so I'm simply looking at whether the X value of their click was greater than 100 or not, and whether the Y value was greater than 100 or not. And that would tell me which quadrant they clicked in, and therefore I can display the color name within a message box. And you'll see the 4 examples there of how that works. In Visual Basic, we have 2 types of methods. We have subprocedures and functions. But in C# we really just have functions, although we can have a voided function that operates like a subprocedure. Our functions are declared in a declaration structure of an accessibility keyword, usually either private or public, which determines who can access this procedure. Sort of like you could fly a public airline, or you could fly a private jet someplace. But unless you are the pilot, or you know the pilot, or you know the owner of the jet, you can't get on it. Public airline, anybody can buy a ticket and fly. And that's how accessibility works within C# functions. Functions that are private can only be utilized within that particular class. Functions that are public can be accessed outside of the class. We'll look more at that down the road. Then there's a return type. So functions return some type of data. It could be a string, could be Boolean, could be a float. In the case of a subprocedure or a voided function, that return type is void. And that's what all of our event procedures were. They were type void. They didn't return anything. Then there's the function name. And then after that is a list of parameters inside parentheses. And those parameters are optional. We could have a function without any parameters. We would still have the parentheses. So here's a couple examples of voided functions that operate as subprocedures like you may have seen in Visual Basic. So the first one here is private void South Mountain. South Mountain is the name, and there's nothing inside the parentheses as parameters. And all that little method does is show a message box saying welcome to SMCC. Then I have a second one here of the name is My Cool Visual Basic Procedure. It's going to receive a string data that's going to go into a variable named XYZ. We're going to use that within the code to take that string XYZ and reverse it. And that's what that little for loop does there. And then the third option here, or third example, is public void another method. And here I'm passing it two values. One's an integer and one's a double, and they're separated by a comma. So the question becomes then, since these are not triggered by events, how do we actually execute this code? Well, here are those same functions that are called from within another procedure, in this case an event procedure. When I click the button named BTN Demo, the first thing it's going to do is execute the line of South Mountain. It's going to go look for a function named South Mountain and execute that function, in which case it's going to bring up a message box that says welcome to SMCC. Then it's going to return control back to that calling procedure. And it's going to execute the next line. I'm going to create a string variable called myString and put South Mountain Community College in the string. Then I'm going to call the myCoolVisualBasic procedure function and pass it the value of my string, which is, in this case, South Mountain Community College. That's the value that's going to go into XYZ in our function. So we're going to use that in a loop in which I'm going to start with the very last letter and decrement until I get to the first letter, and each time I'm going to concatenate a string with the letter at that position of I. And then I'm going to put that value into a label called LBL output, into the text value of that label. And the result, as you can see in that little second box here, is going to put South Mountain Community College written backwards in the label. Once that is done, it's going to return back to the calling statement and execute the next line of code. It creates a variable called x, which is an integer, puts 5 in it. A y variable, which is of type double, puts 3.14. And then I'm going to call another function called another method and pass it x and y. So x is 5 and y is 3.14. The value of x goes into my integer variable here of def. So that it maintains the order. So the first variable passed is going to be the first one received in the parameters. And then y is going to go into ABC. So def takes on the value of x, which is 5. ABC takes on the value of 3.14. Then I'll multiply those two values together and reassign it back to ABC and bring up a message box that says the value of another method is, and I'm going to show the string value of ABC. And so 5 times 3.14 is 15.7, and that's what we see come up in the message box. So here's another example. Here I have a method called twice the fun that is going to return an integer value, and it accepts an integer value. So it's going to take an integer, multiply it by 2, and return the result. In essence, it's going to double whatever value is passed to it. In the second one, I've got a function name called getProduct. It's going to receive two integer values, I and j. Inside that function, I'm going to have another variable called k, where I'm going to multiply I times j and place it into k. And then I'm going to return k, but I'm going to return it as a string value, because that is my return data type here. These functions are called from within a event procedure in which I have two variables, x and y, which are integer, z, which is a string. I'm going to place 2 and 5 into x and y. And then x is going to equal twice the fun of x. So I'm going to pass the value of x, which is 2, to my function called twice the fun. 2 is going to go into xyz. And then xyz is going to equal xyz times 2. So I'm going to double that value and I'm going to return xyz. So that value of 4, 2 times 2, comes back to the calling statement. And x equals 4. So I'm going to replace this twice the fun sub x with whatever was returned. The next line, z equals get product x comma y. So I'm going to pass x, which is 4 now, and y, which is 5, to the function called get product. 4 is going to go into I, 5 is going to go into j. In that function, we've got a variable called k, and k is going to equal 4 times 5, or I times j. And I'm going to return k, which is going to be 20. 4 times 5 is 20. But rather than returning an integer, we're going to return the string value. So that comes back into z now equals the string of 20. And then my message box .show the value of z is, and I'm concatenating the value of z. I don't have to convert it to a string because it's already a string. And we see the message box that will be displayed. Here's something to be aware of when working with functions. And that is, if you have multiple paths within a function, every possible path that terminates must end with a return statement. So here I have a switch statement in which I'm passing it some integer, and if they pass it 1, it's going to return a string of alligator. If they pass it 2, it returns a string of bear. If they pass it 3, it returns a string of cheetah, and they pass it 4, it returns a string of donkey. There's a problem here that we get an error, and the error is not all code paths return a value. And the reason for that is if I pass it a 5 or a 12 or a 17, nothing is going to be returned, and that's going to crash the system. So how do we fix that? Well, we simply fix it by adding a default case where it returns nothing if the value is outside of the range of 1 to 4. And that would cause our error to go away. Well, why use this modular approach using functions? There's some huge advantages to modularizing the code. One is that multiple methods can reuse blocks of code without having that code being duplicated. We simply refer to it each time. You might have several event procedures that will do some of the same things, and by blocking that code into functions, you can greatly reduce the amount of code you have to write. You can also then use those methods, those functions, which are now standalone, in other programs. So that little function that doubled the value could be copied and pasted in the other application and referenced by passing the value and receiving the value back. By breaking our program up into multiple functions, it makes the code much easier to read. We have smaller snippets of code to read, and it therefore makes it easier to debug. We now know it's fairly easy to figure out where something's going wrong and look at a smaller piece of code to figure out what's going on there. It's ideal for a team environment because different members of the team can be working on different functions. And it can then just be assembled and have the different pieces work together. It is an essential in object-oriented programming, which is really what C# is all about. We're going to do some class creation a little bit later in the semester, and we'll be writing methods along with creating properties. But we've used methods already for the objects that are pre-built in C#. So for a list box, we had a clear method that cleared the items of that list box. Objects have hide and show methods that basically affect the visibility property. And we've seen the focus method of putting the cursor in a text box. In object-oriented programming, there's something called encapsulation. Encapsulation is the protection of data. In reality, when we're getting a property such as text out of a text box, that text property is a public method of accessing some value in that class, which has been protected. We can't access the data of that text directly. We use it through a getter method that returns property called text. Pretty much every programming language today is modularized using functions.